Hello and welcome to my walkthrough of a nonlinear Schrödinger equation question. Let's have a look at the question. It asks us to find a square-integrable positive even function phi x satisfying the nonlinear Schrödinger equation as below, where alpha is a positive constant. So basically, we just need to find a equation for phi x. So the first thing we can do is we rewrite the equation, but then we divide across by minus h bar squared over 2m. And this gives us this, and we can let lambda squared equals 2ma over h bar squared, and mu squared equals minus 2me over h bar squared as well. And this makes our equation look a little bit simpler, as the expression at the front of the phi's become single variables. Next, what we're going to do is we're going to divide by mu, and this will give us this equation. And if we take lambda squared over mu squared, we get all of this, but our 2m over h bar squares will cancel, and we'll get alpha over e, which we can let equal gamma squared. So gamma squared equals alpha over e. Substituting this in, we get our gamma squared in front of our phi to the 3, and we can simply rearrange and take our gamma squared phi to the 3 over to the right hand side. And what we're going to do here is we're going to let omega equal mu x, as this will simplify the left hand side of the equation, as it will be d squared phi over d omega squared. Now, the second derivative of phi with respect to omega is the same as the first derivative of phi with respect to omega derived with respect to omega, if that makes sense. But it looks like this, and we can let f equal our d phi over d omega. So d squared phi over d omega squared equals df over d omega. And we can expand this out a little bit, as our d phi's would cancel in this case. But notice how d phi over d omega is the same as the f that we let it be. So we get f equals d phi over d omega. And we can substitute this back into the equation that we had before, which takes away our second derivative and makes our equation just look a little bit nicer. And we can take our d phi to one side, and now what we have here is on the left hand side all f's, and on the right hand side it's all phi's with a little gamma there. So that's what we had before. Now what we can do is we can integrate both sides with respect to f and with respect to d phi, and we get this result. Now timesing it across by 2 just makes it all look a little bit nicer. But for a confined function, we can let c equal 0. So here's our expression. We get d squared phi over d omega squared equals phi squared minus gamma squared over 2 phi to the 4. Now, if we square root both sides, we get plus or minus the square root of the right-hand side. But for a decaying wave, we assume that d phi over d omega is smaller than 0. So we take the negative part of this solution, and we can rearrange to get d omega equals d phi over what was our right hand side before. Now here we take a factor of gamma squared over 2 phi to the 4 out of our bracket that is inside of our square root, as we can take this completely out of the square root. Now if we let g equal 1 over gamma over root 2 phi, dg over d phi is 1 over minus gamma over root 2 phi squared, which is exactly what we have at the front. So we can let dg go to the front, our d phi's cancel, and we get dg over square root of 2 over gamma squared phi squared minus 1 equals d omega. Now remember that our g squared from before can be shown as 1 over gamma squared over 2 phi squared, or rearranged to 2 over gamma squared phi squared. and we can substitute our g inside of our square root, giving us this result. Now we can integrate both sides, and we know that this equals the inverse of cosh. This is just a standard formula that one has to remember, and we get omega plus c. Now, remembering what our variables were, we can substitute back into the equation, which gives us root 2 over gamma phi equals cosh mu x plus c. We've just moved the inverse cosh over to the right hand side there. And rearranging this, we can get an expression for phi. Now remembering that gamma is alpha over e and mu squared is minus 2me over h bar squared, we can substitute this all back in and get one big formula for our wave function. And this is the final solution to this question. Thank you very much for watching. If you have noticed any mistakes that I've made throughout this video, please let me know and I will make sure to correct them as soon as possible. Thank you very much. Bye.